Hi, so today we're going to learn about the cast rule. So the first thing to understand are terminal arm diagrams. So the pink arm right here, that's called the terminal arm, and the purple arm right here, that's the initial arm. Whenever we have to draw a terminal arm greater than 90 degrees, we do it out from here or from here or from here, and the angle that we'd be looking for quadrant 2 would be from here all the way up to here. Or for quadrant 3, from here all the way up to here. Or for quadrant 4, from here all the way up to here. So the formulas for finding theta in the different quadrants are as follows. So for quadrant 1, it's just theta, so whatever the angle is, that's it. You don't add or subtract anything to it. For quadrant 2, it's 180 degrees minus theta, so whatever the angle is, it's 180 minus the angle. For quadrant 3, it's 180 degrees plus the angle. For quadrant 4, it's 360 degrees minus theta, or the angle. So the next thing you need to learn is the cast rule. So it's written as C-A-S-T, and that's just a way to remember it. The A represents that all ratios are positive in the first quadrant, so that includes tan, cosine, and sine. The S represents that all sine ratios are positive in the second quadrant. The T represents that all tan ratios are positive in the third quadrant, and then the C represents that all cosine ratios are positive in the fourth quadrant. So some examples are right here. So if you have an angle that says sine theta equals 0.5849, the first thing you would do is determine which quadrants this angle would lie in. So referring back to the cast rule, sine is positive in the first quadrant and the second quadrant. So that's why I drew my terminal arm in the first quadrant and the second quadrant. And that's my theta r, so my related angle, so you write that there, and then you apply the formulas to it. So for quadrant 1, it's just the angle, so 36 degrees. In quadrant 2, it's 180 degrees minus 36 degrees, which is 144 degrees. So the two angles are 36 degrees and 144 degrees. So that's basically it. If you have an angle that's given as cos theta equals 0.5269, the first step you do is once again figure out what quadrants it is in. So for cos, referring back to the cast diagram, cos is positive in the first quadrant and the fourth quadrant. So my terminal arm is in the first quadrant and the fourth quadrant, and my related angle, 32 degrees, that's inverse of that, is written right here. And then I apply my formulas. So quadrant 1 is 32 degrees, and quadrant 4 is 360 degrees minus 32, which is 328 degrees. Our third example is tan theta equals 0.6935. So once again, first determine which quadrant it's in. So tan is positive in the first quadrant and the third quadrant. So my terminal arm diagram is in the first quadrant and the third quadrant. Then figure out the inverse of 0.6935. So type in tan and then inverse it on the calculator, and that gives you an angle of 35 degrees approximately. So then in quadrant 1, the angle is 35 degrees, just 35. In quadrant 2, it's 180 plus 35, which is 215 degrees. So those are for all the positive decimals you're given. If you're given a negative decimal, so cos theta equals negative 0.0152, then you're looking where cos would be negative. So if we know that cos is positive in the first and fourth quadrant, we know that it will be negative in the second and third quadrant. So that's why I drew my terminal arm in the second and third quadrant, and then you just apply your formulas. So for the second quadrant, it's 180 degrees minus 88, which is 92 degrees, and for quadrant 3, it's 180 plus 88 degrees, which is 268 degrees. So that's basically it.